I'm happy to open up the afternoon session. I hope you had something to eat and now some coffee. So I will continue the session or the topic on indoor navigation and give you some insights on the business area where we are in. We are dealing with trade shows, which are a very special segment, very dynamic segment, and I intend to give you some insights on the projects we did with positioning and navigation in large halls and on trade shows, and what went wrong, what might work, or what will work in the future. But to start, to give you some insights, what we are doing in general and where we came from. So Heidelberg Mobile, you might think, what the name and how they relate to navigation services. So we are quite old company in the business. And what we started in 2005, building up a mobile information system for Heidelberg back then. In that times, before iPhone, we had been one of the few companies on the globe that had an infrastructure, mobile service and data. The only other one was Google. And so we have been quite a while in the business of providing mobile location-based services. Previously, quite strongly in the tourism domain. But in the recent years, we migrated or opened up new business segments, and currently we are doing we're targeting three segments. One is event industry. There we are provider of the largest trade show applications. For example, the IFA was done by us, or the IAA trade show, the CeBIT trade show, Hanover Fair. So the large German trade show applications has been done by my company. And this aspect of orientation is of importance. And then we have in segment enterprise mobility, and some of the technologies that we are using in our applications is open to the public to be used and enhance mobile applications with indoor navigation services. Here's an example of what we do. That was CeBIT this year. And as you can see, for large trade shows, people are in a hurry. They need to inform themselves about the new products, competitors, meet the people they know, take care of their business network. And so orientation, navigation is of great importance. And on the other hand, the trade show business is a very delicate business because the spatial situation changes quite rapidly. You can imagine before the trade show, the hall is almost empty, and suddenly 2-3 days before the trade show starts, then huge logistical processes started, and every company is building up his booths, and the security is going around, and you have the catering service. So there's a huge dynamic, and we try to deal with this dynamic with our competencies and with the help of partners. What we do is, we are as company focusing on mapping and routing. That's the core of our business in this segment. The positioning is not done by us. There we are evaluating from the different possibilities. You have seen previously the positioning with image recognition and then the representation in an augmented reality view. But there are many, many other technical possibilities to get a sort of precise position indoors. And the main challenge for us is, on the one side, the positioning, on the other side, to get precise and accurate spatial data. And we've seen in the previous talks that we had been discussing on OpenStreetMap and crowd-based spatial data, but in many business scenarios that does not work because the data is proprietary. You cannot enter the buildings, they are in private hand, so you need other means to get this sort of spatial data to then build upon them some navigation use cases. And what we try to do is to combine the spatial, the GIS world with all this mapping around buildings and all this exterior data with the inside world, so the CAD world, where architects have constructed the buildings and they have some sort of data format available, CAD files, and what we do is we combine all these different sorts of data to one spatial representation. What is done there is you aggregate the data, you need to do some georeferencing, you need to do a validation, and often the data is too crowded. There are a lot of information inside that is not necessarily usable or feasible for navigation purposes. For example, some wiring of electricity or some pipes for the water. That's not relevant. That might be in the CAD data. So you need to get rid of it. You need to generalize the data and then do a proper visualization. If you deal with indoor location-based service or navigation services, you have 4 different domains that you need to address. On the one side, I mentioned already, the spatial data, where does the data come from? Especially in indoor scenarios, you need quite precise spatial data and you need data that is up to date. In indoor scenarios, during the day, some doors might be closed, or in the evening, there might be security restrictions that you are not allowed to enter certain areas. And for navigation purposes, this needs to be reflected in the spatial data. One example, for example, at CB trade show, whenever some of you might have been there are the parties later in the evening. And then the security is closing in the hall some doors, and only 1 or 2 are open. And quite often you are searching around which fucking door is open. How do I get out of the hall and go to bed? So those are the problems that you have to deal with on the spatial data side. From the positioning side, there are different aspects on the technology side. So, for example, you need, if you want to provide indoor location-based service, you need to have almost precise position. But the more precise position you want to get, the more expensive it is. And often you are then in the balance, how much can an infrastructure provider, how much can a trade show owner afford for this trade show? So you need to balance precision versus cost. And then you have the user side. For precise position, you need, or the devices need to compute quite often the different sensor information to one aggregated position, and that's energy. The energy consumption is quite high, and then in a trade show scenario, if you compute the precise position, but the battery is drained after 2 hours, then your user might also not be very happy. So that's the area of positioning, how to get this position. On the other hand, in consumer scenarios, then you are in the difficulties that you want to address a large audience, but we all know the devices are getting manifold, so you have variations of Android operating systems on device form factors with different sensors, with different precision of information that is gathered by the sensor, the calibration, and there you need to see which audience you are targeting and which devices you are targeting, and where is the restriction that you limit yourself. For example, if you go for a Wi-Fi based positioning, then you might be out of luck on iOS, or if you go for a beacon positioning, a couple of months ago there had not been a beacon equivalent on Android, or on Microsoft there is still no beacon equivalent available, so you need to deal with this aspect as well. And then the 4th dimension is, of course, the user experience. We had been speaking about maps in the previous talks, that we want to have nice maps, but for indoor scenarios, the indoor buildings are quite complex. You have different floors, you have different layers, and the user situation is, especially in trade shows, you don't want to stare on the map all the time, because you need to go there, you need to see the different other exhibitors. So you have to be very careful how the user experience is integrated, or the spatial information is integrated into a nice and good user experience. And then the 5th dimension is the administration and the cost of administering position infrastructure, the mapping infrastructure, because a beacon as such costs €1 or €2, so that's not very expensive, but it runs out of battery after, depending on the signal frequency, 3 months, 2 years, and then you need to replace it, and that's a process that is, of course, also time and cost intense. If you consider different positioning possibilities, On a wireless spectrum, there are different approaches. The basic approach is you have a sensoring or a transmitting device that's transmitting some position, and you have a receiver, and then you get this device is connecting to this submitting entity. That's called cell of origin. If you combine this with signal strength, then you can define the distance from the sender to the receiver. If you then enhance it with how many signals and how many transmitters you get, then you go to the fingerprinting, and then the most complex one is if you go for triangulation and trilateration, that you define the angles of signals that you get. And depending on the approach, it's getting more and more complex, it gets more and more fragile and more error prone, and you need to define and see how much precision do you need for the use cases, for the user experience, and how much budget do you have. So on the positioning technologies, there are a wide array of possibilities that you can go for. Of course, GNSS is the method to choose for outdoor positioning, and the receivers on the devices are getting more and more or getting better and better. So in some trade show halls, the GPS is still working because the walls are not that thick. Then you can go for positioning with 3D network, carrier-based positioning. In LTE, there is a specific location protocol that one can use. Then another approach would be choosing Wi-Fi for positioning. But Wi-Fi in trade shows, if you have ever been to a technical conference, every exhibitor has his own Wi-Fi, and then you have the experience that you have 300, 400 different Wi-Fi networks in one hall, so the wireless spectrum is totally polluted and you won't get any connectivity at all. Then different tags or marker-based approaches. For example, the most prominent one is with iBeacon or Eddystone, or the more classical one with QR tags or image markers. And then there is a wide range of other approaches, for example, using the magnetic field. A very promising one is using inertial sensors on the device. And as we have seen, the previous talk, doing image recognition and then using the camera for the positioning. We did in the last couple of years various beacon scenarios at trade shows, and I want to share with you some insights on how those projects went and where have been the pitfalls, especially focusing on the trade show scenario. And as I mentioned, in trade shows you have this time constraint that you have only 2 or 3 days before the trade show, when the spatial setup is being built, to deploy wireless or beacon infrastructure. So it's very time consuming, and the spatial situation is changing and the wireless infrastructure is changing. You're building it up, and you need to be on the process side. You need proper tools to do a deployment very fast, to do the mounting of the device, the configuration of the beacons, which major minor sensors they are sending. So that's a very critical process that needs to be very efficient. Nowadays, almost all beacon provider has now his own application to do this a little bit better. Quite often they have, for example, no map installed, so that you need to see on a paper map where I'm putting the beacon. So that's a thing that could be optimized in the future. And of course, you need to take care of the configuration of the beacon setup as such. Then a very challenging thing is with the current beacon setup, most beacon providers require some online connectivity to see a beacon is quite a dumb, small thing, sending out an ID, and the infrastructure of the beacon provider is then searching for this ID and then triggering some information, for example, presenting an ad or jumping to an URL on the web. But those systems are currently targeted for normal deployment with an average load. But if you run a trade show with 200, 300 300,000 people a day generating a lot of traffic on this infrastructure, and suddenly you get in the position that the device receives an ID, but the backend infrastructure is not capable to load or to handle the load of this setup, and then the experience is quite bad because it takes 2-3 minutes until the notification pops up, and the user is asking, oh, what the hell is going on? It doesn't work because of this different level of load and connectivity. Then for beacons, one must have in mind that beacons are intended and tailored for push messaging, and one can exploit them for positioning purpose, but the initial intent was to provide some means to engage users, to engage mobile users, to get their attention. And most beacon infrastructure providers have their system tailored for these push messaging services and not for the navigation services. So the setup, the configuration, the positioning of the beacons, that's currently not in there. There might be in the near future, but currently the backend services of those beacon providers are mainly tailored for campaigns and push messaging. Then another thing is the user experience. As I said, it's mainly tailored for push messaging and not for the navigation purpose. Quite often the software development kits that you get from the beacon providers are tailored for this advertisement domain and not giving a coordinate back or triggering some information that the map pops up or stuff like that. Another example or some other things I want to share with you is on Wi-Fi. Wi-Fi is quite ubiquitous. Almost every trade show has a Wi-Fi network in different levels. And for Wi-Fi positioning, you can have two technical approaches. One is a client-side approach that on the client or the mobile client is computing the position based on different Wi-Fi routers he sees around or different signal strengths he gets. That's the client-side approach. And then there is a server-side approach where some central box is sensing around which Wi-Fi, which mobile devices he can see at a certain point in time at a location, and then is computing the position out of that. For the client-side approach, one has to have in mind that to get precise position and precise radio signal strength map, you need to map the location, and that's in the trade show business also quite complex process, like in the beacon setup. So you have a very short time frame to measure everything, and the difficulty is here in this setup that you might have measured the surrounding of a hall, how many Wi-Fi you can see, but the situation changes because at 9 o'clock in the morning, every exhibitor is coming to his booth, and then the first thing what he does, he switches on his own Wi-Fi, and suddenly the complete setup is in a different state, and the positioning approach quite often cannot handle this flexibility and the instant that suddenly 200 or 300 more Wi-Fi access points with different signals are popping up. On the server-side approach, you have the challenge that there are different technologies from Cisco and all other Wi-Fi carriers are working on that to have centralized positioning engines on their back end that measure via their routers the different positions of the mobile clients. But to use this on the mobile client, you need to have some sort of connectivity. That I'm, as a mobile client, can ask a server, say, oh, I'm device from Mathias, give me the position map that I can put it on the map or get a route to, I don't know, to a destination. And for this, you need to have some connectivity. And often in trade shows, the connectivity is quite poor, and then you get also some latency effects. Another thing that I mentioned earlier is device and operation system support. Currently on iOS, you are not able to use a client-side approach as Apple has locked this a couple of operating systems versions before. One can imagine that sooner or later they come up with their own approach on that. or working on that. Another thing is the accuracy and latency for centralized positioning technologies. If you have a massive load on the network, we have experience in Hanover. We do a positioning with a Cisco infrastructure. It takes sometimes 3 or 4 minutes for the central server to compute all these positions and to get a single position of the user back. And 3 or 4 minutes in a pedestrian scenario is not the way to go for. So there are some improvements needs to be done. So conclusion, currently there is no silver bullet for indoor positioning at trade shows. One need to assemble a different technologies depending on the spatial setup the trade show is in, the use cases you want to propagate or utilize in your mobile application, whether it's more on the messaging side or whether it's more on the real navigation side. And what we try to do is we try to mix different approaches. One approach that has a broad coverage provides a medium precise position with some hotspots where you have very precise position, and then you can have a good user experience. And what's also important that you have always a fallback solution, and the fallback solution is quite often the user himself. Give him good possibilities to orientate himself on a map or in a different setup. They say, I'm at IBM now, or I am at I don't know where, and then that's a thing to go for. All right, so that's for the moment the experience I want to share with you guys. I'm open for question.
Good talk. Any point? I think also all the points were very, very realistic in that sense that events are exactly that. The very last minutes, things are there, being forgotten, being set up. Also, we are human bodies with a lot of water.
Exactly. Halls are empty and suddenly
change dramatically the Wi-Fi landscape. And that's it. No other point? Or you were so impressed? It was quite wide and also a good describing one. So the current, there's not, let's say, the solution currently, but there's one. Point.
Hi, Gregory. It strikes me that there's maybe a different problem. Well, there's a problem, but it's different. That is, the trade show organisers need to be stricter on Wi-Fi routers or something. And actually, your locations would be solved by that, but also the things like the connectivity, you know, if they're supplying the Wi-Fi and saying exhibitors can't have theirs or limiting them.
Some are doing this, then they have the restrictions, only use public Wi-Fi, only broadcast on this channel with this power range. So some of them have this. Unfortunately for the tech conferences, the trade show providers are not in a strong position. They want to have the exhibitors. And then there's, I need Wi-Fi to demonstrate my own solution. I don't want to pay a fortune for your public Wi-Fi or the official one. I need to bring mine, otherwise I won't come. And then, especially the large tech trade shows, then they are not strong enough to push or to restrict to an official Wi-Fi setup.
Hi, my name is Amir. I have a question about the beacons. So first of all, you need to have the Bluetooth turned on, right? So that's one thing. Secondly, what's the conversion rate you see there? How many people do click on the notifications? How do they perceive that?
30 to 40%. That's 40
to 50.
Yeah. Usually you should have some communication, and when the user installs the mobile application, if you want to have a better service, enable your Bluetooth, and then we can provide you more precise position information, or you can have some benefit for advertisement or for coupons. So the new technology needs to be always aligned with a communication strategy to inform the user what's going on. Also, there's a lot of data collected in the background, and the user should be informed that this is done, and that he can switch off the position technology, for example.
So that's 40% of the people who installed the app, right?
No, from the install base, 40% then have Bluetooth enabled. And the install base, that's also a matter of communication, whether the app is in time ready. We did the small application for this event, that was a small hack. Unfortunately, on iOS, we submitted it on Monday. It's not there yet, so.
On the other hand, this is the really realistic part. That's very often the traditional IT solutions are too small, or too slow, not dynamically enough. If I would have a change because Lufthansa starts to strike, so what to do then? So a lot of things in these event parts are still, let's say, in a way not so flexible. So it's also very difficult if I just take a picture, and I have a picture here, and I would like to pass this picture to Thomas here, just to do something else, send it to the world. We know that the simple passing a picture is currently not easy. And there are some techniques where, like Android Beam, but they're simply not yet known. Yeah. But maybe there is also next 10 years, a next generation of thoughts, and people start to want to see something new, and then they're getting excited about this. Thanks very much again for this talk.